welcome to the March gathering of the Denver Amazon Web Services User Group. I'm David McDaniel, Director of Cloud Professional Services at Nginx Technologies. You can reach me at mac@nginx.io or david@mobile-360.com. My LinkedIn and our Twitter handles are there as well. Our agenda for tonight is our standard communication items. Upcoming meetups are a little bit up in the air right now because of the coronavirus. I've got what's new with AWS, and tonight's topic, hands-on Nginx containers with ECS. As usual, our Slack channel is Denver AWS Users Group.slack.com. You can email me for an invite. We have our Twitter handle at Denver AWS UG. I will usually make announcements about the meetups. We are listed on the official Amazon AWS user group site. And send me any announcements you have the day before the meetup, and I'll get a slide in here for you. As I said, we've got today's meetup, April 15th. I'm still working on topics because certain presenters don't have the ability to be recorded or stream online. So I'm working through those issues now. The updates for this month, a lot's been going on. Elasticache has global data store for Redis now. So you can have a globally distributed Redis using Elasticache. RDS Postgre offers global databases as well. Data Lifecycle Manager, part of the backup suite, adds support for 1 hour backup interval. Apparently they have to come out with a new release for every different interval. RDS Performance Insights now supports RDS for MySQL 8, even though MySQL 8 has been part of RDS for several years now. Redshift had 2 or 3 major announcements, which are really pretty good. The first is materialized views. So when you have lots of data and create a view, it can now be materialized, so you don't have to recreate it on every SQL query. It also has Redshift has pause and resume for like dev and test environments. It's not the cheapest service, so now you can save some money by pausing and resuming your Redshift clusters. In AWS fashion of creating everything you could possibly want or need, BottleRocket is AWS open source Linux-based operating system, purpose-built to run containers. So think about Alpine, but it's already got like the ECS agent pre-installed and all the things that are really tailored for container-based operating. ECS now supports Secrets Manager, so you can configure ECS to pull secrets right from Secrets Manager. Don't have to do that your own way. For those using Terraform, there is now a cool tool called Chekhov, chekhov.io. It has a Terraform static analysis tool. So it will analyze your Terraform code in your CI/CD pipeline before actually executing it. Aurora PostgreSQL can now do in-place upgrades from 9.6 to version 10. And for those who are using Nitro with their built-in hardware level encryption, you now get an EBS volume performance increase of 36%. Redshift also announced column level access controls. So now instead of having to split tables into 2 to be able to restrict access by user to different sets of data, you can just do it on a column level. Elasticsearch has updated to version 7.4, and for those using the compute savings plan, Lambda is now part of that. The list here of regions and zones just keeps growing. Some of the interesting ones, at US West 2 in Oregon now has 4 AZs. There's a couple, Canada and Beijing, that have only 2, which is unusual. And this list does not include the local zones, which there are now 2 of, one being in LA and the other being in Australia, I think. Can't remember. We'll move on from questions. We'll ask questions online as you have them, or unmute your mic. And we'll move right to the main topic. All right, so I'm going to go ahead and switch over to, let's see. So here you can see I had a cluster, but oh, I really thought I deleted all that. Huh, I just built it all. So that was a mistake. I meant to delete all this before the meetup started so we could run through it. But you can see right here, I actually just did a Terraform apply, and it created all of my infrastructure I need for an entire ECS cluster, the Mac Meetup cluster. And you can see it's got one running service. Has anybody done much with ECS yet?
I have not.
So ECS in general is Amazon's kind of own way of doing Kubernetes, if you will. They have two services for running containers. Primarily, they actually have a third. So there's ECS, the Elastic Container Service. They have EKS, which is actually running Kubernetes, Amazon's copy of the open source Kubernetes, and they actually have Elastic Beanstalk, which can run containers as well. Beanstalk is really nice if you just have like a Tomcat, WAR file, or IIS deployment, and you can just throw it out there and it will automatically scale. And it's pretty nice, but if you want to do things a little more advanced, ECS or EKS is the way to go. We're doing some big projects with ECS with some customers. Sorry. ECS is made up of a couple pieces. First, there's the ECR, which is the container repository. So this is like Docker Hub, or there's a number of different container repositories out there, and this is Amazon's. So I've created a repository named Mac Meetup, and I've got a couple images pushed here. You see I pushed the last one at 3:56 today. It's got a size, it's got your digests, and it's got your URI. So I've taken that URI and put it into my task definition. So if you look at the way ECS breaks things up is you've got tasks, and this is the task definition and revision. So it took me 7 tries to get it right. The interesting thing about this is the network mode and the compatibilities. So the network mode says that we're deploying this into an AWS VPC. That and the combination of Fargate deployment model says that AWS, the ECS service, is going to deploy all your tasks and services into compute that are under control of AWS, and you don't really have visibility into. It will deploy multiple services per node, but it's automatically scales, automatically creates more and deletes excess as your load goes up and down. So you don't see the EC2 nodes, you just see your services running and scaling. And that makes it a lot more efficient for workloads that have kind of wild swings in demand. So if you've got a very popular website or a web application that really is only used during the daytime by businesses and not at night on weekends, this may be a good option for you because you don't have to worry about scaling the number of compute nodes behind your cluster. You can see you can allocate per task an amount of memory and CPU limit. These are in units, and so this is basically a quarter of a vCPU. You can define the container. So I've done all this in Terraform, and I'm happy to share the Terraform code with anybody who wants it. And one of the nice things is I've set it up so that we've got logging into CloudWatch. So if I go over here, go to CloudWatch, created a few log groups, and they're kind of random, but there's a container here, and you can see this is the actual output of my Nginx log file. So I can see all the gets. This is the access log, and error log will be here too. You can see here's an error log entry. I don't have a favicon.ico file. Then there's some console outputs. This is another piece of the log. There's a whole telemetry setup with ECS that will give you lots of information about when services are started and stopped, tasks started and stopped. In an Nginx environment, you're probably going to have the service always running and then just scaling automatically. So we'll go over here and we'll go into the cluster itself. The nice thing about the cluster is you can actually have tasks and services that are in either deployment mode. So if you were to add EC2 nodes in this cluster and then tell different tasks to run on EC2, you could have some running EC2 and some running in Fargate as well. So a service contains multiple tasks. So I can go into my service, and you can see that it now has a number of tasks. In this case, it's only one. And you can see we have a desired count of one instance and a running count of one instance. So I can go into the task itself and see that it's running. Nice thing is you see everything it's built. Basically, the way the compute works is it's running in a AWS service VPC, but it attaches an ENI for every service, and if you ask it to, it gives it a public IP address. You'll always have a private IP address, so you can do service-to-service communication if you're doing a microservice API, for example. But in this case, you can see I've taken my ECR image and the latest version and deployed it here. And now you can see the logs are set up in this region, the stream prefix. There's all sorts of stuff you can do, very, very similar to Kubernetes, where you can have volumes mounted, Docker labels, extra hosts, elastic inference. There's a ton you can do. You can do your own network bindings if that's what you really want. But the nice thing about the Fargate deployment is it takes care of a lot of that for you. You assign it a role. So the task role, this is basically the equivalent of your EC2 instance profile or instance role, so that your various tasks can have different IAM permissions. So if a particular task needs to access SQS or SNS or S3, this role would then have those permissions. Just to prove everything is working, I can go over here to the public IP, and you can see Nginx comes right up. And this, of course, is the default page. But if we were to go back up and go in to the service, we can update the service. and say we want 5 running now. You click through, now the service is updated. Now you can see our desired count is 5. Our running count is 1. So obviously it's going to notice the difference. And it will start, has started 4 tasks. So now we've got 4 more tasks that are provisioning. The one we had originally is running. And as we go into, as they become running, they will each get their own IP address, different than the first one. I should probably wait for it to actually become running. It takes about 30 seconds with this image. It's not blazingly fast, but I didn't do anything in particular to make a really small image. You can see it was 66 megabytes. So there's our Nginx. So now we've got 5 different Nginx servers, and there's a couple different ways you can manage that. You can have ECS create load balancers. You can create load balancers. So if we went into EC2, and this is the part I didn't quite get to. But I was following an example. Internet facing. And we're going to make it to all the availability zones. Then I've got a security group. No, you don't do this, you do IPs. And then you'd be able to put in your IPs. Now this doesn't work great when you're scaling up and down automatically. This is more for a fixed number of services. If you had 5 Nginx instances running all the time, you could add them to a load balancer and then have load balanced access. The other way you can do it is from within ECS. You can go into the service. I don't know that you can update this once you've created it, but maybe you can. Okay, so load balancing can only be set up on service creation. So let's create a new service. So another thing ECS does it will automatically build you a blue-green deployment using code deploy. You can also do, if you were doing a web service API, you could do automatic service discovery integration, and that would integrate AWS App Mesh and Cloud Map. And I'm not sure if you would have to manually deploy like the Envoy sidecar or if it does that automatically. I haven't got quite to that point yet. I'm going to disable service integration because these aren't services. But basically what I'm doing is I'm just telling it to deploy into our IP, and into our VPC rather, using our subnet groups. Set up our security group. And then here you can say, let's do a load balancer. Oh, and I guess you have to create one. Okay. Don't know what. I guess I don't have to add targets at this point. But now we have our load balancer, or it's provisioning at least. There we go. So now you have the load balancer, ECS will find it and allow you to do your port mapping. And then again, we're not doing app mesh. Please configure a container with ELB. Oh, I see. You have to click add. Obviously, I didn't get to this. Existing listener for your load balancer. Oh, there we go. Path pattern. Gotta have a health check or else it doesn't know if the services are up or down. I'm not sure about this. Okay. Well, there you go. In a few minutes, we've got auto scaling. So I'm gonna stop. I'm gonna delete my original service so we can play with the load scaled one, the automatically scaled one. So it registered 5 targets. Oh, look at that. So it's using the private networking. So the good thing is between the load balancer and the ECS cluster, everything's private networking. And then you can see what it's done is out of the 5 it's creating, putting 1 in 2B and 2H and 2A and 2C. And once these come up, it'll probably take 30 seconds or so. The healthy threshold is 5 times every 30 seconds. So it'll take 2.5 minutes. Yeah, I'm not getting anything. So while this is going on, does anybody have any questions? Sergey, how does this compare with your experience with Azure? Sergey, can you hear me? Oh, it looks like Sergey left. Okay. All right. Let's see how these are doing. Okay, passing. So if we look at, there should be a, where's the URL? Oh, this is the target group. So URL for the, here it is. So basically this created a record in my Route 53, which I can then put a CNAME in front of. And this might be because oh, the load balancer is actually still provisioning, even though the targets, there we go. The only thing is I think it's listening on 80. Yeah. Okay, let's just check the rules. Oh, if path. Okay, so that was the part I was confused about. So that path we put in required a certain path for the ALB. So the way the ECS set up this load balancer was it wanted a rule for a specific path to send to the load balancer, and then if it didn't match any other rule, it would also send it to the load balancer. So we could pretty much, I wonder if we can delete the entire rule. Well, okay. Let's see if I can go there now. There we go. The one thing I was trying to, and don't know that I got done, there may be a URL. I really need to look at this. So I think I put this /adder in, and this should give me the service address. I have not ever tested this. Yeah, it didn't work. So I got a question, how to compare ECS to EKS pricing. I have not been down the EKS pricing. It would be something that the AWS Simple Monthly Calculator could help you address. It will give you the base costs, but unfortunately, Greg, I'm sorry, I haven't been down that road yet. Oh, this is interesting. It looks like it set it up to 2 different load balancer target groups. Okay, shouldn't matter because they're all the same targets. Oh, unless this never got any targets. Okay, that's the issue. So we want to edit this one and forward to the other. Now, you can do some really amazing things with the ALB. You can have it forward to weighted distribution of different target groups, enable stickiness for certain durations. Okay. So now they're both going to send it to the same request. Okay, so the problem is I did not get the location set up right. And I was trying to get it to dump out the server IP address so we could refresh this and see different IP addresses, but I am certainly not an Nginx guru and obviously did not get this quite right. But overall, I think we made some very interesting progress here. So I was going to try to keep this to about an hour. So we're about 8 minutes up on the hour for tonight. Another question, if I set up 1,000 containers with images in ECS, would it be easy to convert to EKS? Well, EKS does, you can still use basically the same repository. So your images would probably want to get updated depending on how you do the deployments. If you had used ECS optimized images in EKS, it will run the ECS agent, which really won't give you any benefit. So it's just extra bloat. So if you were running images that did not have the ECS agent and it was just a base like Alpine image, it would be not bad to use the same image. You would have to do, the big change would be coming in configuring the services and pods to have the appropriate sidecars like Envoy and Pilot and all those different aspects of using an Istio service mesh. Kind of the cool thing about AWS App Mesh and Kubernetes-based deployment is both of them use the Envoy sidecar. So they're actually quite compatible. We're actually trying to do a POC for a client now with Amazon ECS and a console-based, App Mesh-based, and console from HashiCorp distributed service mesh with on-prem services using console, and then we're going to add in GKE using Istio and try to have one very dynamically distributed multi-cloud and hybrid service mesh. That's going to be a fun POC. Yes, it will be very tricky if we can get it to work. But I've seen it work with AWS App Mesh, console, and on-prem using console. So really the big trick is to get it to work with GKA as well, which I actually don't think will be too hard, since that's where most of this came from. Any other questions? Yeah, I wish I could send you all a virtual beer. Maybe Amazon will start delivering beer with their drones. I do miss having the beer and pizza and seeing all you guys face to face. But I hope this was helpful, and stay tuned, and we'll get this recording posted here soon, and we'll also schedule some more meetups. If anybody has any requests for meetups, feel free to email me or contact me on Meetup. And I guess until next time, unless somebody has some questions, we'll see y'all in a month. Thank you all very much for coming.
Thanks. Have a good evening.
Appreciate it.
Thanks, Max.